Hello all. In this video we will discuss about object life cycle. So as the name says object life cycle, we will talk about the lifespan of the object in Java. In the previous video stack and heap we already discussed where the variables in Java live. Like local variables live on stack and the instance variables live on the heap. So we already discussed about that. In this video, we will discuss how long those variables live. What is the lifespan of those variables? Okay. So before discussing that, we all know that there are two kinds of variables in Java. One is local variables and the other one is instance variables, right? So first we will discuss the lifespan of the local variables. Okay. Now let's see that with an example. Okay, if you look here, I have written a read-off method. Okay, this is one of the method that is present in test life 1 class. So in this read-off method, like assume this read-off method is getting invoked by someone else. Okay, so when someone invokes read-off method, what happens is there is a stack memory on in the Java, and this particular read-off method will be pushed onto the stack. So basically a stack frame gets created for this read-off method. Okay, and inside this read-off method it will check what are all the variables that are present. So whatever variables that are present inside this method are called local variables. So if you look here, there is only one variable that is present inside read-off method. So first it executes first step, int s equal to 42. So integer, it's not a reference variable, it's a Java defined data type. That's why, and we know the size of the integer data type as 4 bytes. So inside this read-off stack frame, what happens is there will be 4 bytes that gets allocated for this yes variable. Okay, and inside that it will store the value 42. Okay, now what is the second step here? Sleep off method. So it invokes sleep off method. Okay, now when it invokes sleep off method, a new stack frame gets created for sleep off method. Okay, and then whatever the statements that are present in sleep off method gets executed. Now what we are trying to do here is we are trying to assign 7 value to x. And if you look here, read of present, s is present in read of method, but it's not present in the sleep of method. It will throw error, and even if you see, it is throwing the warning saying you cannot resolve symbol. So why is that happening? So basically, if you consider the local variables, there are two kinds, like we can define them as two kinds. Okay, one is whether that particular variable is alive or not, and another one is whether that particular variable is in scope or not. So there are two definitions for a variable, whether it's alive or not and whether it is in scope or not. We can use variables only if they are in scope. So what does that mean? Now if you see here, S variable is present in the stack. Okay, it's present in the stack. It's present in read of stack frame. But as soon as sleep of method gets executed, as soon as this particular line start getting executed, control from read of method has gone to sleep of method, and a new stack frame got created for sleep off, right? So now whatever the variables that are, as soon as the control has gone to the another method, all the variables that are present in read of method will go out of scope. Okay, the objects are alive, the variables are alive. We can say that variables are alive as long as these local variables, I am talking specially about local variables, as long as the local variables are present on the stack. Okay, as long as these variables are present on the stack, you can say that variable is alive. But whenever you call another method from a method, like whenever you call sleep off from read off, then the control will go to sleep off and all the variables that are present in read off will go out of scope. So, and there is a simple technique which you like using which you can say whether that particular variable is in scope or not. Now you see these are the stack frames, right? So whatever the variable that are or whichever variables that are present in sleep of stack frame, or we can say those variables are in scope, and the remaining variables remaining variables that are present in read of, though they are alive, you can't, those are out of scope. Whichever variables that are present on the topmost stack frame are the variables that are in scope. And Java, and we can use only the variables that are in scope. Now here when sleep of gets executed, there is a new stack frame that got created for sleep of, and this S variable has gone out of scope. Okay, the variable is alive but it's not in scope. That's why when you are trying to use S here, it's throwing error. Okay, so though the variables are alive, you have to consider the scope as well. And in Java, we can use the variables only if they are in scope. Now, once the sleep of method is executed, then this particular 6th line statement is completed and 7th line gets executed. So, sleep of method execution is completed. Then what happens? This sleep of gets popped out. It gets popped out from the stack, and then you can see only read of method stack frame. Now what is the topmost stack frame here? Read of is the topmost stack frame. So whatever variable that is present inside the read of stack frame, you can say that that particular variable are in scope. Now S has come into the scope again, and then you can use the S variable. Here I am trying to print system.out.println. Yes, it is working. It's not throwing any error. Okay, so we can say the variables are used only when they are in scope. Now once the read of method is completed, once the read of method execution is completed, then what happens? This read of stack frame gets popped out. Now you don't see S variable on the stack, then you can say that that particular variable is dead. Okay, so local variables are, we can say local variables are alive as long as they are present on the stack. If they are not present on the stack, then you can say that the variables are dead. So that is the lifespan of the local variables. Local variable lifespan is as long as they are present on the stack. Okay, then otherwise they are dead. Okay, now we will understand this with the help of one more example. Okay, if you see here, do stuff of method. Okay, now in the do stuff of method, if you see here, there is a do stuff of method. Assume that someone else is calling this do stuff of method, and as soon as this method starts executing, we all know that this particular a stack frame gets created for this do stuff of method. And inside this, how many variables are there? You have only one variable, and since this is a Java defined data type, here bytes get byte gets allocated for B variable. Okay, on the stack you can see only do stuff of. Now this B variable is live and it is in scope as well. You can consider that variable as alive because it is present on the stack, and you are saying that it is in scope because that is the topmost stack frame. Do stuff of is the topmost stack frame, and whatever variable that are present in the topmost stack frame are considered they are in scope, right? Now what happens is, let's say from after the first statement, it is giving control to go off method gets executed. As soon as the go off method gets executed, a new stack frame gets created on top of go off method, and whatever variables that are present inside the go off method, those will be allocated inside the stack frame. Okay, inside the go off method you have X and Z variables. Okay, X and Z variables you have, and then it will call the crazy of method. Now if you see, when go off method was invoked, you can see there are two variables X and Z, and there is another variable that is present in do stuff of stack frame. So basically all these three variables are alive, but only X and Z are in scope. B is out of scope because the variable that are present in the topmost stack frame are X and Z. Okay, now you can use only X and Z. If you try to use B, then you will get an error. Okay, now go off method this particular statement got executed, and then it is invoking crazy of. When it is calling another method named crazy of, then a separate stack frame gets created for crazy of on top of go of. Now, and whatever the variables that are present inside the crazy of, those will get allocated in the stack frame. So here there is a variable named C. So inside crazy of, you can see a variable C. Okay, that got allocated. Now, all these four variables C, X, Z, B, all these are alive, but only C is in scope, and these X, Z and B are out of scope because those are not present in the topmost stack frame. Okay. Now let's see, this crazy of got completed. Okay. As soon as crazy of got completed, crazy of gets popped out from the stack. When it gets popped out from the stack, even C gets popped out, right? Now C is not present on the stack. You can say that C variable is dead. Okay. So C variable was alive only when go of invoked crazy of method, and then till the time it got popped off from the stack. Only that was the time it was alive. Okay. Now crazy of is completed. Now go off. If you see, go off also gets completed. Now in the do stuff, like after calling the crazy of method, go off also it reached the end of the method. Okay, and go off also gets popped out from the stack. When go off gets popped out from the stack, these X and Z variables are dead. Okay, because you don't see these variables on top of the stack. Now after go off got completed, then do stuff of also gets popped out, and then B variable also will be dead. Okay, this is the lifespan of these variables. These are all called the like whatever we have discussed till now, it's the local variable lifespan. And now let's discuss one more example for the local variables only. Till now what we have discussed only the Java defined data types. We did not discuss about the reference variables. Now let's talk about the reference variables. Okay, so let's consider a person is invoking foof of method. Okay, now as soon as foof of method gets invoked, what happens, this particular stack frame gets created for foof of on the stack. Okay, and a stack frame got created on stack. Okay, that got created. And let's see what are all the variables that are present inside the foof of. There are no variables that are present. Now control has been given to barf of method because we are invoking barf of method. Now a separate on top of the foof of another stack frame gets created for barf of method. Now if you look here inside barf of method, you have a reference variable duckd, and for that like you can, a memory got allocated for D variable, and it is assigned new duck of object. Okay, and we all know that objects gets created on the heap. Okay, so on heap, this new duck of, first one is duckd. For duckd, this is a reference variable. On the stack itself, a reference variable got created, and for new duck of object got created on the heap. Okay, because of this equal sign, this duckd is assigned to this heap object. Okay, to this duck object. Now what you can see here, now the D reference variable is alive and it is in scope. Okay, so you can use this D variable, and D is assigned to this duck object. Now when barf of method gets completed, it goes to foof of. When barf of method gets completed, then what happens, this gets popped out from the stack. So which means that this reference variable is dead. Okay, if you see, this particular duckd reference variable will be dead because this is not present on the stack. But what about this particular object which is present on the heap? You are just popping out the reference variable, you are not popping out the object, right? In previous examples, what happened is, these are all Java defined data types where the value gets assigned inside the stack frame. So as soon as the stack, as soon as the frame gets popped out, you don't see that value and you don't see that reference variable, you don't see that variable as well. But here, since this is a reference variable, you are just popping out the reference variable but not the object. The object is still lying on the heap. Here comes the Java garbage collector. Okay, whenever you pop barf of D also gets popped out from the stack and D is dead. At that time there is no reference. This reference is cancelled because whatever the assignment that was done to the duck object, it's gone. Okay, like we all know, right? Reference variable is just a remote control to the duck object. So let's say you have x, y and z methods, so you will have buttons on this. Okay, you will have buttons on this. Now since this particular remote is not there, you can't since this particular remote control is not there, you can't access this object. So basically this particular reference is not there, this particular connection is not there when barf of gets popped out. So what Java garbage collector does is, it will go to the heap. Okay, it will go to the heap and it will scan all objects that are present on the heap, and it will see whether there are any references for that object or not. Okay, if there are references, then it will leave the object as is, but if there are no references, garbage collector removes that object from the heap and it gives you a free space. It cleans up space for you. Okay, now let's say let's consider that it called barf of and you created a reference variable and there is an object on the heap. Now let's say the garbage collector has come. Okay, when the garbage collector has come, it will find the duck object and it will see, okay, there is a reference, like there are references to the duck object because there is a reference variable D that got assigned for this duck object, so I should not clean up. As soon as barf of gets popped out from the stack, then this particular reference is removed, and next time when garbage collector comes here, what it understands is, okay, there is a duck object and there are no references to it. Now it's time for me to clean up the space. Okay, so this way reference variables gets cleaned up by the garbage collector. Okay, if you don't clean this, now automatically instance variable, like for the local variables, if those are Java defined data types, as soon as you pop out the stack frame, then those will get cleaned up. But the reference variables, just the variables are getting cleaned up, but not the objects. Okay, that's why Java garbage collector does this work for you. If Java garbage collector doesn't do this work, okay, then there will be plenty of objects lying on the heap which are unused, and at some point of time you will run out of memory and this will lead to a failure. You can't even run the program. Okay, to prevent that situation, Java garbage collector, it cleans up space for you by removing all unused objects. When I say unused objects, there are no references for the objects. If an object is not having any reference, then that is considered as an unused object. So basically, now see, usually how you will reach this duck object, by using a reference variable. Reference variable is nothing but you have a remote control and there are buttons on it, and whenever, let's say there are XYZ methods, right, then you have XYZ buttons here as well. Whenever you press X button, then it will invoke the X method. If you press Y button, it will invoke Y method. Now when there are no references, means when there are no remote control, then how will you even execute methods on the duck object? You can't use that. Okay, that's why garbage collector does that. Okay, now so we understood what is the lifespan of the local variables. Lifespan of the local variables is as long as the variables are present on the stack. Okay, if that is a Java based data type, then as soon as the stack frame gets popped out, then that particular variable is considered dead. Okay, even it's the same for reference variables as well. As soon as it gets popped out, the reference variable is considered dead, but the objects that got assigned to still remain on the heap, and Java garbage collector takes care of cleaning those. Okay, now coming to the instance variables. So even in the instance variables also, you can have two kinds. Okay, so usually whenever you say you can have two kinds. One is Java defined data types, and one more is the reference variable. So inside the object also, instance variables are of two types. Now if you see here, what I can see is, maybe you can say private int size. Okay, and you can say private duck. Okay. Now here these are the instance variables, and one instance variable is Java defined data type and another instance variable is a reference variable. Okay. Now if you look here, let's say you create a object. Okay, now you create an object. I create an object for new stack reference. Okay, this is an object. There is a remote control for me, like how remote control for me, which can access this object. And inside this object, how many variables are there? Int size and duck d. For int size, anyway, we know how many bytes we have for size. Okay, integer variable, and 4 bits get allocated. And for duck, okay, for duck, what happens is this is a reference variable. Okay, this is all heap. I will draw. This is all heap. Okay, now there is a reference variable duck d. This is an object and there is a reference variable here, and this is all complete heap. This object is on heap and there is a duck object that gets created and this reference variable is assigned here. Okay, and this is how object looks. So first you have created one object, okay, stack reference object. Someone from the main method is calling stack reference equal to new stack reference. As soon as new stack reference is called, there is an object that this is all heap. Okay, this is all heap. So then a new object got created on the heap. This is called stack reference, and inside that how many variables you have? Size and duck. Okay, for size it got created, and for duck this is a reference variable, so duck got created on the heap, and for that it's a reference variable. Okay, now what is the lifespan of this int size and duck d? Okay, now we all know someone has created this object and there is a reference variable. Like what I can do is, let me explain here. Now inside this, this is the pictorial representation of what I have shown you till now. Whenever they have done stack reference, new stack, this is a new stack reference and this is the reference variable. Okay, so reference variable is pointing to this object, and the variables inside this object like size and duck are alive as long as there is a reference, because to reach these variables you have to have this reference. If there is no reference, then you can't reach out. Okay, now this object or these instance variables are alive as long as there is a pointer to this. Once this pointer is broken, once this reference variable is gone, then there will be no connection. So when this reference is gone, then you don't have any way of reaching this object. Okay, there are no references, and when the garbage collector runs for the next time, then it will say there are no references for this object, and then it will clean up this one and this one as well. Because now to reach this duck object, first what people do, they take this reference variable and reference variable dot duck they will take. Okay, and let's say this reference variable is duck. Okay, reference variable dot d, and then d dot, they'll invoke methods on this. First of all, this reference variable itself is gone. First the first connection itself is gone. Then how will you reach this connection? Because to reach this duck you have to have this connection, and to get this connection you have to have this particular object connection. Then that is not there. Okay, so the lifespan of the instance variables are as long as there are pointers to that object. Okay, as long as there are pointers to the object to which it belongs, then the instance variables are alive. Whereas for the stack, as long as the objects are on the stack, which means as long as the method is executing, then the instance local variables are alive. Local variable lifespan is less compared to the instance variables. Okay, now we understood, right? So for the objects on the heap to get cleaned up, then there should be no references. Okay, and there should be no references. Okay, how should we do that? How can you make an object not having references? There are three ways of doing so. One is, if you see here, if you go to main of method, okay, main of method, now what happens, I created stack reference equal to new stack reference. As soon as this main method execution is completed, Okay, as soon as this main method execution is completed, this stack reference method, so when main method starts getting executed, right, there will be stack frame that got created for main of method, and inside this you will have a reference variable stack reference, which is pointing to objects that got created on the heap. Now when the main of method execution is completed, then the stack reference variable is gone. Okay, this reference variable is gone, and this object is free for garbage collector. Okay, that is one way. When there is no scope, when the object is out of scope, then these references will be removed. And one more thing is, you can also remove the references to an object by assigning it to a different reference. Now let's say this is a reference object. Initially you assigned it to one duck object. Okay, now you want to clean up this space. One more thing is, you just remove switch reference from first object to second object. In this case, this connection is removed and this object is free for garbage collection, right? This is one more way. And the another way is, just assign this reference variable to null. Okay, when you assign it to null, then this connection will be removed. Okay, when you are assigning it to null, basically what you are saying, you have a reference variable but you don't have any connection, okay, with any live object. When you say that you don't have any connection, or when you are assigning null, which means that whatever buttons you have, those are not working. Okay, let's consider TV remote which is not functioning. How many ever buttons or how many ever times you press the button, you don't see anything working or any channel changing on the TV, because there is no program. The same way, when you assign it to null, this remote control is just a dummy remote control, because there is no object assigned to it. Okay, so to recap what we discussed about the lifespan of the variables in Java. There are two kinds of variables, local and the instance variables. Okay, local variables live as long as the variables are on the stack, or basically as long as the method is executing. And there are two kinds, whether a variable is alive or whether a variable is in scope. Okay, if the variable is in scope, then only we'll be able to use it. And if there is a reference variable, then objects cleaning will be taken care by the garbage collector. And coming to the instance variables will be live as long as there are references to it. Okay, once the references is gone, all the instance variables will be dead. Okay, hope you understood it. Thank you.